Hello, problem solvers. Today we're going to look at another example of how to solve a problem using an easier related problem. Here is a somewhat famous problem that I think is pretty interesting. So let's take a look. In the mythical land of Kantanu, it is considered good luck to own goats. Barsanta owned some goats at the time of her death and willed them to her children. To her firstborn, she willed half of her goats. Now, the will was drawn up long before her death and was written in general terms. That's why there's not a specific number. That's just a fraction. To her secondborn, she willed 1/3 of her goats, and last she gave 1/9 of her goats to her thirdborn, the black sheep among goat owners. As it turned out, Barsanta died. When Barsanta died, she had 17 goats. Barring Solomonic approach, how should the goats be divided? So if you start thinking about what you need to do, it's pretty straightforward. You need to find out what half of 17 is. But you will quickly discover that there is an issue with that, because if you do half of 17, you will realize it is not a whole number because 17 is odd. And, can't give somebody half a goat. So we then need to figure out what to do. Now you could use your calculator and do, some fractions and get some decimals, but instead, a way to use this strategy is to just make this number an easier number to work with. So an easier number to work with would be something even or like 16 or 18. You could do half of 16 pretty easily or half of 18 pretty easily, but then this second fraction you've got to work with is 1/3, and so you'll probably discover that 18 is divisible by 3. So what we're going to do here is I'm just going to use an easier number and say, okay, let's just pretend she had 18 goats, and half of 18 is 9 goats to the oldest, and 1/3 of 18 is 6 goats to the second child, and then the third child gets 1/9 of the goats, and 1/9 of 18 actually also works out nicely, which means this was a much better choice, and that's 2 goats to the thirdborn child. But, she doesn't have 18 goats, she has 17, so basically, did I give away an extra goat? Well, the weird thing here is let's add these up. 9 plus 6 is 15, plus 2 is 17. So basically, if you look at these numbers and add them up, we only gave away 17 goats, but I rounded it up to 18 goats. So what happened to the extra goat? And this is why this is a famous math problem, because of this weird contradiction that you get. And basically, why this is happening is because of some original assumption that actually turns out to not be true. If you look at these numbers here, 1/2 and 1/3 and 1/9, if you add them up, you actually don't get 1. So her original will didn't distribute all of the goats. It left out some of the goats because half of the goats plus 1/3 of the goats plus 1/9 will not equal all of the goats. So it turns out by rounding up to 18, we found a way to give away the 17 goats in a way that matches the will, because the will wasn't drawn up very well. It didn't say what to do with some of the goats. In fact, if you add up all the those fractions, you actually get 17/18. Yeah, I think that's all I wanted to say about that one. So here is your homework. Make sure you're using this strategy and writing an explanation, and please let me know if you have any questions.